In this video, the solution to problem number 40 that was uploaded on 14th December of 2020 itself will be discussed. This is also the right place to mention that this is a problem similar to the JAM 2019 problem uploaded as well as solved on the 13th of December of 2020. We start the solution by remembering the definition of flux of a vector function f over an arbitrary closed surface which is mathematically stated in equation 1. So please pay attention to equation 1. And as known to us, it is the surface integral of the dot product of f vector and elementary surface vector. These important facts are also mentioned in a box just adjacent to equation 1. Please take note of that. Surface integral of the dot product of f vector and elementary surface vector. Now the most important thing to realize for solving this problem is that here the surface under consideration lies on the xz plane with y being held constant at the value 0. And as the surface points along negative y-axis, I repeat, and as the surface points along negative y-axis, the surface vector is at 90 degree with x and z component of the vector function f, while the surface makes an angle of 180 degree or pi radian with the y component of the vector function f. So, on taking dot product with the area vector, only the y component of the vector function f supplied in the problem and rewritten in equation 2 will matter. So for the time being, please pay attention to equation 2, which gives you the vector function already mentioned in the problem. And other important findings from the ongoing discussion are summarized in equations 3 and in equation 4, which states ds equal to dx dz, which is obvious, and y is equal to 0, which is also obvious from the discussion. So effectively, the problem reduces to evaluating the double integral in equation 5. Please pay attention to equation 5 just below the diagram. The procedure of evaluating the double integral is now shown in equation 6, from which the answer, that is the value of the flux phi, comes out to be equal to 0.33. Both equations 5 and 6, and as a matter of fact all the equations are very important for this problem, so please pay very close attention to all those equations. And as is obvious from this discussion and this mode of solution that the answer is 0.33, which is mentioned twice on the board to facilitate the viewers, and as instructed in the question in itself, the answer has been rounded off to 2 decimal places. So the answer, I repeat again, is 0.33. I hope that the solution is clear to all of you after watching this video. Thanks for watching.